In the vacuum of deep space, a sphere of gas, rock, and iron, 30 times the mass of Earth, is moving at 2 million miles per hour. It emits no visible light. It reflects no neighboring stars. It is a perfect, freezing phantom, radiating thermal energy at a temperature barely 3 degrees above absolute zero. To a human observer, or even the vast majority of our most advanced optical telescopes, this massive object is mathematically indistinguishable from the pitch-black void behind it. Its albedo is practically non-existent, but its mass is undeniable. Its gravity quietly warps the microscopic dust paths in its wake, bending the fabric of space-time just enough to leave a ghost trail, a silent titan marching through the absolute dark. We are deeply conditioned by our evolution to believe that our solar system is a walled garden, a secure, predictable clockwork mechanism governed by the furious, sustaining fusion of our local star. The sun dictates the elliptical paths of the 8 known planets, forming what feels like a gravitational sanctuary against the violent chaos of the Milky Way. We intuitively imagine the outer boundary of our system, the distant shell of the Oort Cloud, as a sealed vault door protecting us from the interstellar wilderness. But the architecture of the cosmos is not built on walls. It is built on probabilities, open systems, and vast, terrifying intersections. Our sun's gravitational domain is highly porous. The void between stars is not a barren, empty ocean. Recent orbital simulations, gravitational microlensing surveys, and deep infrared anomalies have begun to sketch a chilling physical reality. There is a staggering amount of invisible mass drifting through the interstellar medium. We are not talking about theoretical dark matter, rogue comets, or wandering asteroids. We are talking about fully formed, hypermassive planetary bodies. These are worlds violently stripped from their parent stars, ejected into the endless galactic winter during the chaotic billiard ball infancy of their stellar neighborhoods. The latest statistical models suggest these orphans do not just exist, they outnumber the stars in our galaxy by an order of magnitude, and the relentless mathematics of their trajectories point to a disturbing inevitability. These wandering leviathans do not simply stay out in the deep, isolated ocean of the galaxy. They drift through the populated systems. Right now, somewhere in the freezing, lightless outer reaches of our own solar system, an object of unimaginable scale could be quietly piercing our heliosphere, unseen, unheard, a wandering giant, entirely undetectable until its immense gravitational wake begins to drag at the orbits of our outermost comets. This is the hidden architecture of reality, a universe defined not by its shining, welcoming stars, but by its wandering, freezing anomalies in the dark. If you seek the truth in the dark, subscribe and join us on this journey. We are about to step into the void. Block 2 #. For thousands of years, humanity looked up at the night sky and saw a profound, comforting lie. We saw permanence. The constellations were fixed, anchored against the dark like diamonds set in black velvet. The wandering stars, the planets, moved across the ecliptic in predictable, rhythmic patterns. This visual consistency birthed a deep-seated psychological bias that still infects modern thought, the illusion of the clockwork universe. From the Aristotelian spheres of antiquity to Ptolemy's intricate epicycles, and finally to the elegant, sweeping ellipses formulated by Johannes Kepler. Our ancestors desperately wanted the cosmos to be a machine of perfect, divine order. We needed the dark to be structured. We needed the void to be safe. When Isaac Newton published the Principia Mathematica in 1687, he handed humanity the ultimate mathematical key to this clockwork illusion. Newton demonstrated that the force pulling an apple to the ground was the exact same force holding the moon in its orbit. His universal law of gravitation was breathtaking in its simplicity and predictive power. With it, we could calculate the exact position of Jupiter's centuries into the future. We built mechanical orreries, beautiful brass contraptions with gears and cogs, perfectly mimicking the solar system. We looked at these models and convinced ourselves that reality was just as clean, just as stable, a star in the center, planets in their lanes, and an impenetrable, empty void everywhere else. But this sense of security was built on a mathematical oversimplification. Newton's equations were perfect for a two-body problem, describing the gravitational dance between exactly two isolated masses, like a single star and a single planet. The reality of the universe, however, is never isolated. In the late 19th century, the French mathematician Henri Poincaré attempted to solve the seemingly simple three-body problem, seeking a general equation to predict the orbital paths of three massive objects interacting gravitationally over time. What Poincaré discovered shattered the illusion of the clockwork universe forever. He found that the equations did not lead to a neat, predictable equilibrium. They led to chaos. Even the most microscopic deviation in the initial position or velocity of one body would compound exponentially over time, violently altering the entire system. Poincaré proved that orbital mechanics at a multiplanetary scale is inherently unstable. The brass gears of the orrery were a fantasy. The solar system is less like a perfect clock and more like a chaotic, high-stakes game of billiards played on a frictionless table, where the balls never stop moving and the table itself is constantly warping. To understand why the galaxy is teeming with invisible, wandering worlds, we must strip away the sanitized imagery of our current solar system and look at the brutal thermodynamics and orbital violence of planetary formation. Stars do not form in quiet isolation. They ignite deep within, collapsing, turbulent, molecular clouds, vast, stellar nurseries spanning dozens of light years, churning with hydrogen gas, silicate dust, and intense magnetic fields. As a central protostar gathers mass, conservation of angular momentum forces the surrounding material to flatten into a spinning, superheated accretion disk. This is the violent crucible of planetary genesis. Within this disk, microscopic dust grains collide and fuse, building planetesimals, which in turn violently crash into one another to form planetary embryos. It is an era of constant, apocalyptic bombardment. During the first few million years of a star system's life, it is heavily overpopulated. Gas giants, vast spheres of hydrogen and helium, millions of times more massive than Earth, begin to carve out lanes in the protoplanetary disk, but their orbits are not stable. Due to a process called planetary migration, these behemoths interact with the remaining gas and dust, losing orbital energy and spiraling inward toward their host star. As a Jupiter-class giant plows through the inner system, its massive gravitational well acts like a cosmic wrecking ball. The delicate, developing orbits of smaller, rocky worlds are utterly destroyed. But the most catastrophic events occur when two massive gas giants or fully formed planetary embryos cross paths. When two immense gravitational fields intersect, the rules of the three-body problem dictate a violent resolution. They do not collide. They engage in a high-speed gravitational dance, exchanging colossal amounts of kinetic energy and angular momentum. In physics, there is a strict threshold called escape velocity, dictated by the mass of the host star and the distance from it. The equation $V_E equals SQRT frac is the absolute mathematical boundary between belonging to a star system and being condemned to the void. If a planet is accelerated beyond this velocity during a chaotic gravitational encounter, the star can no longer hold it. The mathematics of the encounter demand a sacrifice. To stabilize the orbit of one giant planet, another must be violently hurled outward. Imagine a spinning top placed on a rapidly vibrating table. For a moment, it maintains its balance, holding its position through sheer momentum. But the invisible forces beneath it are compounding. Suddenly, an imperceptible shift in the frequency of the vibration catches the edge of the top, and in a fraction of a second, it is violently ejected from the table, spinning out into the dark of the room. This is the exact mechanism of a planetary ejection. A world, fully formed, perhaps with a churning iron core, a thick atmosphere, and oceans of liquid water, is suddenly subjected to a massive gravitational slingshot. Over the course of a few short years, a microscopic blip in cosmic time, its orbit becomes highly eccentric. It pulls further and further away from the warm, sustaining glow of its parent star. The psychological terror of this process, if witnessed from the surface of such a world, is difficult to articulate. As the planet accelerates outward, the host star would slowly shrink, transitioning from a blinding, life-giving sun into just another bright point of light in an increasingly black sky. The temperature drops catastrophically. The atmosphere, once a dynamic fluid of swirling weather systems, begins to collapse. Water vapor freezes and falls as a global blizzard. Carbon dioxide solidifies into dry ice, coating the surface in a thick, alien frost. Eventually, even the nitrogen and oxygen liquefy and freeze solid, leaving the planet encased in a hypercryogenic shell of frozen air. The planet crosses the heliopause of its native system, leaving the protective magnetic bubble of its star, and plunges headlong into the interstellar medium. It becomes a rogue, an orphan, a permanent wanderer in the deep dark. For decades, the astronomical community operated under the assumption that these ejections were incredibly rare. It was believed that while the universe is violent, the vast majority of planets remain bound to the stars that birthed them. We built our entire cosmological paradigm around this assumption. We assumed that the spaces between the stars were empty, save for trace amounts of microscopic dust, isolated hydrogen atoms, and the faint, ancient echo of cosmic microwave background radiation. We looked at the night sky and divided reality into two distinct categories: the brilliant islands of light, and the barren, sterile oceans of darkness between them. This binary thinking dictated how we searched the cosmos. We aimed our telescopes almost exclusively at the light. We analyzed the emission spectra of burning stars. We mapped the luminous gas of nebulae, and we catalogued the bright, spiraling arms of distant galaxies. But our visual perception is severely limited by the brutal geometry of light propagation. The inverse square law dictates that the intensity of light radiating from a source drops off exponentially over distance. For a telescope on Earth to see a planet orbiting a distant star, we do not just rely on the light traveling from the star to us. If we are looking for reflected light, we are fighting a losing mathematical battle. The light must first travel from the host star to the planet, suffering the inverse square drop-off. Then, A tiny fraction of that light reflects off the planet's surface and must travel all the way back across the interstellar void to reach our lenses. The intensity of this reflected light decays proportional to the fourth power of the distance. This means that optical astronomy is practically blind to anything that does not generate its own massive nuclear fusion. If you place a Jupiter-sized object just a few light years away from us, sitting in the open interstellar void, no optical telescope ever built by human hands could see it. It is too cold to emit significant infrared radiation, and there is no nearby stellar light for it to reflect. It becomes a perfect ghost. This optical blindness created a massive blind spot in our theoretical models. Because we could not see anything in the dark, we assumed there was nothing there. We confused the limits of our engineering with the limits of reality. We treated the interstellar void as a peaceful, empty vacuum, simply because our instruments were entirely deaf to its silent inhabitants. But the mathematical models of planetary formation continued to mature. As supercomputers grew more powerful, astrophysicists began to run millions of highly detailed on-body simulations, mapping the chaotic infancy of stellar clusters. They recreated the swirling disks, the condensing embryos, and the violent migrations of gas giants. And every single time the supercomputers crunched the numbers, the results presented a terrifying discrepancy. The simulated star systems stabilized, but only by violently shedding mass. The simulations proved that planetary ejection is not an anomaly. It is not a rare, freak accident of celestial mechanics. It is a fundamental, inescapable byproduct of planetary formation. The math was unrelenting. For every solar system that achieves a stable, clockwork equilibrium, dozens of planetary bodies must be thrown into the void. This realization struck the astrophysical community like a cold shock. If the mathematical models were correct, the empty spaces on our star maps were not empty at all. The entire galactic plane was littered with the frozen corpses of exiled worlds. We were suddenly forced to reconcile with a universe where the stars are just the brightly lit buoys floating on an ocean filled with submerged, unseen leviathans. We had built our entire understanding of the cosmos by observing only the objects that scream into the electromagnetic spectrum. But the true bulk of the galaxy's planetary mass might be completely silent, wandering, cold, and unbound by any star. The sheer scale of this invisible population was impossible to calculate using traditional methods. We needed a new way to see in the dark. We needed a way to detect a mass that emits nothing, reflects nothing, and hides perfectly against the ultimate black backdrop of deep space. The barrier to uncovering the truth was absolute, until we realized that while a rogue planet cannot be seen, the massive indentation it makes in the fabric of space-time itself cannot be hidden. Block 3, to perceive the invisible. Astrophysics had to abandon the capture of light and instead measure the geometry of nothingness. If a wandering mass in the deep void emits no radiation, the only proof of its existence is the invisible wake it leaves in the fabric of the universe itself. In 1915, Albert Einstein published the General Theory of Relativity, a framework fundamentally redefining gravity not as an invisible tether pulling objects together, but as the geometric warping of space-time by mass. The core of this revelation is elegantly encoded in the Einstein field equations, written as $G _+ lambda G _ frac T $. The left side of this equation describes the curvature of the void. while the right side represents the distribution of mass and energy. The profound implication here is that space-time is not a passive theater stage where planets act out their orbits. It is a malleable, dynamic medium. When a massively dense object moves through the interstellar vacuum, it drags and bends the coordinate system of reality around it. For decades, this was a beautiful mathematical abstraction, a thought experiment reserved for collapsing stars and supermassive black holes. But as optical engineering caught up with theoretical physics, astronomers realized that this geometric warping provided a terrifyingly precise tool. They called it gravitational microlensing. The concept is brutally simple in theory, yet almost impossibly demanding in practice. Imagine looking at a distant, glowing street lamp through a heavy, moving fog. Now imagine someone silently sliding the curved base of a massive wine glass through your line of sight. The glass itself might be perfectly clear and completely invisible in the dark. But as its curved edge passes exactly between your eye and the distant light, the optical geometry changes. The glass acts as a converging lens, gathering the scattered photons of the background lamp and focusing them directly into your pupil. For a brief, fleeting moment, the street lamp appears to flare with intense, unnatural brightness. This is exactly how we hunt for rogue planets. We cannot see the planet, so we watch the distant, ancient stars of the galactic bulge, waiting for one of them to inexplicably magnify. When a free-floating planet drifts directly between a telescope on Earth and a background star tens of thousands of light-years away, its gravitational field bends the star's light rays. The physics dictating this magnification are absolute, governed by the dimensionless parameter $U, which represents the projected angular separation between the lens and the source. The resulting magnification factor is calculated perfectly by the equation $AU equals frac U sqrt$. As the invisible planet slowly transits the star, the light curve spikes in a perfectly symmetrical, achromatic wave. It does not change color like a stellar flare. It does not repeat like an orbiting moon. It is a singular, ghost-like signature, a silent, mathematical scream from the dark. But the universe does not offer these alignments willingly. The spatial volume of the galaxy is so unimaginably vast that the odds of a rogue planet perfectly crossing the microscopic pinprick of a distant star's light path are astronomically low. To catch a shadow in the act of moving, you cannot just look at one star. You must look at tens of millions of them simultaneously, without blinking, for years on end. In the high, freezing altitude of the Atacama Desert in Chile, isolated from the electromagnetic noise and atmospheric distortion of human civilization, the Las Campanas Observatory stands as a mechanical sentinel against the void. Projects like the Optical Gravitational Lensing Experiment, or OGLE, utilize massive charge-coupled device sensors cooled by liquid nitrogen to a state of near absolute zero, effectively eliminating thermal noise from their own circuitry. Night after night, the automated domes grind open, pointing their mirrors toward the dense, dusty heart of the Milky Way. They take millions of high-resolution exposures, feeding petabytes of raw, undiluted starlight into supercomputers. Algorithms relentlessly sift through this digital ocean, discarding the variable stars, the eclipsing binaries, and the atmospheric artifacts, hunting exclusively for that perfect, symmetrical curve of gravitational magnification. And the duration of that magnification is the ultimate lie detector. If a massive, dead star, like a brown dwarf, passes in front of the background light, its immense gravitational well creates a microlensing event that lasts for several weeks. But if the object is smaller, a rogue planet with the mass of Jupiter, the event is shorter, lasting perhaps a few days. And if the object is a terrestrial, rocky world, an exiled Earth drifting alone, the alignment is incredibly brief. The magnification spike lasts only for a few desperate hours before returning to the flat line of absolute black. When the first definitive data sets from OGLE, and later the K2 mission of the Kepler Space Telescope, were finally compiled and peer-reviewed, the astrophysical community was confronted with a horrifying statistical reality. The microlensing events were not rare anomalies. They were happening with a frequency that completely broke the existing models of galactic architecture. The supercomputers extrapolated the tiny, localized sample size of these light curves across the entire volume of the Milky Way, adjusting for the massive blind spots in our observational geometry. The resulting numbers did not just suggest a few wandering stragglers. The data indicated that there are roughly a few 100 billion stars in our galaxy, but there could be up to 2 trillion free-floating planets. For every single burning star you see in the night sky, there may be 10, 20, perhaps 50 invisible worlds adrift in the freezing dark. The interstellar medium is not an empty vacuum. It is a cosmic graveyard choked with the silent, frozen corpses of exiled worlds. We live in a galaxy where the orphans outnumber the parents by an order of magnitude. To grasp the scale of this mystery, we must force our minds to confront the physical reality of these objects. They are not mere mathematical data points on a microlensing chart. They are physical locations. They are entire, complex worlds with geology, weather, and perhaps, horrifyingly, their own isolated thermodynamics. Imagine an Earth-sized rogue planet violently expelled from its star system 3 billion years ago. On the surface, the conditions are a portrait of absolute, unrelenting death, without the radiant heat of a host star. The surface temperature plummets to roughly 3 degrees Kelvin, sustained only by the faint, ambient microwave background radiation left over from the Big Bang. The atmosphere, once a dynamic fluid of swirling gases, has entirely collapsed. It lies on the barren rock as a layer of hypercryogenic snow. First, the water froze, creating a shell of ice harder than steel. Then the carbon dioxide fell as dry snow. Finally, as the temperature scraped the absolute bottom of the thermodynamic scale, the nitrogen and oxygen oceans liquefied and then solidified. The planet is sealed in a tomb of frozen air, drifting in total, impenetrable darkness. But planetary physics is a discipline of layers, and the death of a world is rarely total. Deep beneath this frozen crust, hundreds of kilometers down, the reality of the rogue planet changes dramatically. The core of a terrestrial planet is an incredibly dense sphere of iron and heavy silicates, heavily seeded with radioactive isotopes incorporated during the violent accretion of its birth. Elements like uranium-238, thorium-232, and potassium-40 are locked within the mantle. As these unstable isotopes slowly decay over billions of years, they release a relentless, steady stream of radiogenic heat. In our solar system, Earth radiates this internal heat out into space. But on a rogue planet, the miles-thick shell of frozen ocean and solidified atmosphere acts as the ultimate cosmic insulator. The heat is trapped deep within the abyssal layers of the planet, where the pressure is millions of times greater than at sea level on Earth. The rock is molten. Volcanoes erupt in absolute darkness. Hydrothermal vents spew superheated, mineral-rich water into enclosed, subsurface oceans. It is entirely mathematically plausible and increasingly accepted in astrobiology that immense, liquid oceans exist beneath the ice shields of these wandering worlds. These oceans would be completely detached from the light of any sun. They would be utterly blind, pressurized, and violently churning with geothermal energy. It is a closed thermodynamic loop, a solitary, hermetically sealed terrarium plunging through the deep void, and wherever there is a stable solvent, like water, a source of chemical energy from hydrothermal vents, and a timeline of billions of years, the brutal, unrelenting mechanics of organic chemistry begin to turn. The terrifying prospect is not just that billions of rogue planets exist, but that some of them might be alive. A blind, pale, deep-sea biosphere evolving over eons, completely unaware of the galaxy outside, imprisoned beneath a ceiling of iron-hard ice, slowly drifting through the interstellar dark. And then there are the gas giants, the rogue Jupiters. These are entirely different beasts, operating on a scale of mass that defies human intuition. When a gas giant is ejected from its star system, it does not freeze solid. Its sheer mass ensures it retains an enormous reserve of primordial heat from its violent formation. As the massive sphere of hydrogen and helium drifts through the vacuum, it slowly, constantly contracts under its own immense gravity. This continuous gravitational compression generates profound amounts of internal friction and thermal energy. A rogue Jupiter is a world of eternal, violent storms operating in the pitch black. The atmosphere is a churning, chaotic, fluid dynamics nightmare, with hypersonic winds tearing across the latitudinal bands. Without a sun to dictate day or night, the weather is driven purely by the immense heat boiling up from the metallic hydrogen core, but it is not entirely devoid of light. The fierce internal convection creates a colossal magnetic dynamo, generating a magnetosphere millions of miles wide. As this magnetic field plows through the sparse, ionized particles of the interstellar medium, it accelerates them into the planet's polar regions, igniting massive, permanent auroras. If you were to approach a rogue gas giant in the deep void, you would not see a brightly lit sphere. You would see a dark, roaring leviathan, faintly silhouetted by the eerie, continuous glow of global lightning storms and sweeping, multicolored auroras blazing across its poles, a screaming, highly energized ghost ship sailing through the void. The existence of these objects forces us to reevaluate the structural integrity of our own existence. For centuries, our maps of the galaxy have been static. We plot the positions of the stars, trace the graceful, sweeping curves of the spiral arms, and imagine the cosmos as a vast, predictable machine. But the stars are merely the anchors. The trillions of rogue planets are the fluid filling the spaces between, and they are not standing still. Every single object in the Milky Way is in motion, bound by the overarching gravitational pull of the supermassive black hole at the galactic center. Our sun travels along a relatively stable, circular orbit through the Orion Cygnus arm, moving at roughly 500,000 miles per hour. We carry our protective bubble, the heliosphere, with us like a lantern in the dark. But the rogue planets do not share our clean, orderly vector. Because they were ejected through violent, chaotic, gravitational encounters, their trajectories are wildly eccentric. They are not confined to the flat, stable plane of the galactic disk. They orbit at steep, erratic inclinations. They plunge down through the galactic plane from the halo, cutting across the established traffic lanes of the star systems. They are moving at tremendous, highly localized velocities, unbound by the orbital synchrony that keeps the neighboring stars at a safe distance. When you look at the math of their vectors intersecting with the sheer, overwhelming density of their population, a chilling realization takes hold. The solar system is not a stationary fortress. It is a ship sailing through a minefield. We are dragging our delicate, gravitationally bound planets through an interstellar medium that is actively swarming with massive, high-velocity projectiles. The void is not a barrier keeping the danger out. The void is the highway they travel on. And the mathematical probability of our paths crossing is not a question of if, but a strictly defined calculation of when. Block for ###, we are confronted with a terrifying paradox of observation. The very mechanism that allowed us to discover the immense population of rogue planets, gravitational microlensing, is entirely useless for detecting one that is actually heading toward us. Microlensing relies on an incredibly specific optical geometry. It requires a dense, brilliantly illuminated backdrop of distant stars, like the luminous core of the galactic bulge, to act as the canvas. We can only see the shadow of a wandering planet when it crosses in front of a searchlight, but the geometry of an impending collision does not offer us a searchlight. If a rogue planet is approaching our solar system from the vast, empty regions above or below the galactic plane, or if it is drifting in from the sparse, starless void of the local interstellar neighborhood, there is no background light to magnify. The canvas is black. The mathematical reality is that an object heading directly for us presents the lowest possible probability of a microlensing event. It is a cosmological blind spot. We have a perfect radar system that only works when the missile is flying sideways, miles away, but is entirely deaf to the one dropping straight down on our heads. This forces astrometry into an agonizing theoretical impasse. If we cannot see the light bending around the object, we must try to detect the thermal radiation of the object itself. But here, the unforgiving thermodynamics of deep space build an impenetrable wall. The interstellar medium is not merely cold, it is a profound thermal vacuum. A rogue terrestrial planet, stripped of its star for billions of years, will have radiated almost all of its residual surface heat into the void. It equalizes with the cosmic microwave background, hovering at a temperature of approximately 2.7 Kelvin, against the deep infrared sensors of our most advanced orbital observatories. Such an object is functionally invisible. It produces no thermal contrast. It is a piece of black ice floating in a black ocean. Even a Jupiter mass rogue, which generates its own internal heat through continuous gravitational contraction, presents an almost insurmountable challenge. Let us analyze the capabilities of the James Webb Space Telescope, the most sensitive infrared eye ever engineered by human civilization. Its mid-infrared instrument, or MIRI, is cooled by a closed-loop helium cryocooler to a staggering 7 degrees Kelvin, specifically to prevent the telescope's own microscopic heat from blinding its beryllium mirrors. MIRI is designed to hunt for the faint, red-shifted glow of the universe's first galaxies. If a rogue Jupiter, radiating at perhaps 150 Kelvin, were sitting in the near-interstellar void, theoretically, Webb could see it. But astronomy is entirely dictated by the inverse square law of radiation, expressed in the brutal mechanics of the Stefan Boltzmann law, $J equals sigma Ty $, where the total energy radiated per unit surface area of a black body is proportional to the fourth power of its thermodynamic temperature. The energy output of a cold gas giant is microscopically faint, As that faint infrared radiation travels across the vast distances of the outer solar system, its intensity drops exponentially. By the time those photons reach the Webb telescope stationed at Lagrange Point 2, the signal is so incredibly weak that it is completely drowned out by the localized thermal noise of our own solar system. It is obscured by the zodiacal light, the faint, glowing dust scattered throughout the ecliptic plane by decaying comets and colliding asteroids. Searching for the thermal signature of a rogue gas giant at the edge of the solar system is like standing in the middle of a brightly lit, neon metropolis during a torrential downpour and trying to spot the glow of a single, dying firefly shivering in the fog 100 miles away. The noise-to-signal ratio is a mathematical brick wall, because direct observation is blocked by the limits of optics and thermodynamics. We are forced to rely on the slowest, most agonizing method of detection in the history of physics: astrometric perturbation. We cannot see the mass, so we must look for the invisible gravitational wreckage it leaves behind. Gravity is an infinite force. Its influence propagates outward forever at the speed of light, decaying, according to Newton's law of universal gravitation, $F equals G, frac $. No matter how massive our sun is, as you travel further into the dark, its gravitational grip becomes incredibly fragile. The boundary of our solar system is not the orbit of Neptune, nor is it the heliopause where the solar wind dies. The true gravitational frontier is the Oort Cloud, a theoretical, spherical shell of trillions of dormant comets and icy planetesimals stretching out to an astonishing 100,000 astronomical units from the Sun. To understand this scale, 1 astronomical unit is the distance from the Earth to the Sun. The Oort Cloud extends almost halfway to the nearest neighboring star, Alpha Centauri. In this freezing abyssal outer rim, the Sun is nothing more than a particularly bright star. The comets out here are barely tethered to our system. Their orbital velocities, dictated by the equation $V equals SQRT, frac $, are agonizingly slow. A single orbit can take millions of years to complete. They are perfectly balanced on a microscopic gravitational knife edge. If a rogue planetary massive, silent gravitational well drifts through this outer shell, it does not need to physically collide with anything to cause an apocalypse. It merely needs to alter the mathematical geometry of the space. As the intruder passes through, its localized gravity violently competes with the distant, weakened pull of the Sun. It creates a moving hill sphere, a region of dominant gravitational influence that sweeps through the dormant comets like a magnetic plow dragging through a field of iron filings. The mechanics of this encounter are governed by a process known as gravitational scattering, and specifically the Kozel-Ledoff mechanism. When a massive tertiary body disturbs a stable, roughly circular orbit, it forces a terrifying exchange between the orbit's inclination and its eccentricity. The math conserves the overall energy of the system, but violently trades the shape of the orbit for its tilt. The comets do not just get nudged, their orbits are stretched into extreme, plunging ellipses. They are violently dislodged from their holding pattern and sent plunging inward, accelerating toward the inner solar system in a relentless death dive. But here is the true horror of the perturbation paradox. The scale of the solar system creates a massive, insurmountable latency in our data. It is a cosmic server lag. If a wandering gas giant breached the outer Oort cloud and initiated a massive gravitational scattering event, disrupting millions of comets, we would not know it happened. The physical distance is too great. A comet dislodged from the outer rim at 50,000 astronomical units, falling inward due to the gravitational scar of a passing rogue, will take tens of thousands of years to cross the void and reach the inner solar system, where our telescopes can finally detect its outgassing tail. We are monitoring a crime scene where the blood takes 10 millennia to hit the floor. If we suddenly see a massive, unexplained surge of long-period comets entering the inner system tomorrow, it does not mean a rogue planet is currently passing through. It means a rogue planet passed through at the dawn of human civilization, silently warped the outer dark, and has long since faded back into the interstellar abyss, leaving a delayed shockwave of kinetic bombardment in its wake. The intruder is a ghost, and the comets are the delayed shrapnel. This forces astronomers to look closer to the inner edge of the dark, seeking gravitational anomalies that happen on a faster timescale. We look to the Kuiper Belt, the ring of frozen debris just beyond Neptune, and when we apply the cold, rigorous mathematics of orbital mechanics to this region, the numbers do not add up. The data is broken. The precedent for this kind of mathematical detective work is deeply rooted in astronomical history. In the mid-19th century, astronomers mapping the orbit of Uranus discovered a baffling anomaly. The planet was not where Newtonian physics dictated it should be. It was moving too fast at certain points in its orbit, and too slow at others. It was being dragged by an invisible mass. In 1846, the French mathematician Urbain Le Verrier sat at his desk and, using nothing but pure mathematics and celestial mechanics, calculated the exact mass, trajectory, and position of the unseen perturbing body. He sent a letter to the Berlin Observatory with coordinates, famously declaring that he had discovered a planet with the point of his pen. The very next night, astronomers pointed their telescope at the exact coordinates Le Verrier provided, and they found Neptune. It was the ultimate triumph of mathematical physics over the darkness of space. Today, astrophysicists are attempting to replicate Le Verrier's triumph, but the anomalies they are tracking are far more subtle and far more terrifying. We have discovered a bizarre population of extreme trans-Neptunian objects, or ETNOs, bodies like Sedna, a dwarf planet on a massive, highly elliptical orbit that takes 11,400 years to complete. When astrodynamicists mapped the orbits of the most distant ETNOs, they found a glaring, impossible pattern. Their perihelia, the points in their orbits closest to the Sun, are all clustered together in the same quadrant of the solar system. Their orbital planes are all tilted at roughly the same anomalous angle. The sheer statistical probability of this clustering occurring by random, chaotic chance in the vast 360-degree volume of the outer solar system is roughly 0.007%. The universe rarely tolerates such blatant mathematical coincidences without a massive physical driver. This anomaly birthed the famous Planet 9 hypothesis, proposed by researchers Konstantin Batygin and Michael Brown at Caltech. To balance the equations, to make the architecture of the outer solar system mathematically sound, their supercomputer simulations demand the existence of a massive, unseen, perturbing body, a dark world, roughly 5 to 10 times the mass of Earth, lurking on a highly eccentric orbit deep in the lightless void beyond the Kuiper Belt, acting as a gravitational shepherd, silently corralling the distant ice worlds into this bizarre alignment. But the scientific community is fractured, and the debate reveals the true limit of our observational power. Despite years of searching, the exact swaths of the sky predicted by the models using the Subaru telescope in Hawaii and scanning archives of infrared data, Planet 9 has not been found. The equations scream that a massive object must be there to warp the space, but the telescopes see only blackness. This failure has given rise to a much darker, much more unsettling interpretation of the Sedna anomaly. The math assumes that the perturbing mass is a resident of our solar system, trapped in a long, stable orbit, but the equations of gravitational scattering do not require the mass to stay. The clustering of the Etianos could be a transient scar. Imagine an empty metropolis at 3 in the morning. A massive, heavy transport truck blows through a quiet intersection at high speed, violently scattering a flock of resting birds, forcing them into a chaotic, swirling pattern before they settle back down on different ledges. If you arrive at the intersection 5 minutes later, the truck is miles away, completely vanished from sight. But by analyzing the panicked, disrupted positions of the birds, you can mathematically prove that a massive object of specific dimensions and velocity recently passed through. What if the bizarre clustering of objects beyond Neptune is not the work of a resident Planet 9? What if it is the gravitational wake of a rogue planet, a wandering super-Earth, or a frozen Neptune that plunged down through the galactic plane, pierced the outer heliosphere, dragged the orbits of the ice dwarfs into a clustered anomaly, and is currently accelerating back out into the deep interstellar medium, leaving us completely oblivious to its passing? Or, far more terrifyingly, what if the anomaly is not a scar from the past? What if the slow, agonizingly slight shifts in the orbits of the extreme trans-Neptunian objects are happening right now because the massive, invisible intruder is currently on its inward trajectory? Astrophysics relies on the concept of the galactic collision rate, formulated as $Z equals n sigma v $, where z is the frequency of encounters, n is the number density of rogue planets in the interstellar medium, sigma is the gravitational cross-section of our solar system, and v is the relative velocity. For decades, we assumed the value of n was practically zero. We thought the void was empty, but microlensing surveys have radically altered the equation. If there are trillions of rogue planets drifting through the Milky Way, the value of n is staggeringly high. The cross-section of the Oort Cloud is an immense, porous target. The relative velocity of objects unanchored from the galactic rotation curve is extreme. When you plug the new, terrifying variables into the equation, the collision rate shifts from an impossible anomaly to an absolute statistical inevitability. The solar system is plowing through a heavily populated, invisible minefield. The mathematics dictate that intersections must occur, but because of the severe limits of thermodynamics, the inverse square law of light, and the agonizing latency of orbital mechanics, our warning systems are fundamentally broken. We are left in a state of hypervigilance, analyzing the microscopic jitter of distant pulsars. We use pulsar timing arrays, measuring the precise millisecond radio pulses of dead stars thousands of light-years away. If a massive, invisible rogue planet were quietly drifting through our local stellar neighborhood, its gravity would slightly alter the barycenter of our entire solar system. The sun itself would wobble, ever so slightly, off its axis. This wobble would create an incredibly faint Doppler shift in the timing of the pulsar signals reaching Earth. We are straining to hear the microscopic change in the rhythm of the galaxy's metronomes, desperately trying to detect the silent, crushing weight of an approaching phantom. But the data is noisy. The background hum of the universe is loud, and the anomalies we are currently detecting in the timing arrays remain stubbornly, terrifyingly unresolved. Block 5 we live under the delusion of permanence, because human civilization has flourished during a microscopic, incredibly stable window of geological time. A mere 10,000 years of the Holocene epoch have falsely concluded that the solar system is a safe harbor. We mistake our temporary, localized luck for a universal constant. But the mathematics of orbital mechanics do not care about our need for security. The survival of Earth is not a guaranteed property of the cosmos. It is a precarious, ongoing balancing act, a fleeting equilibrium in a galaxy dominated by chaotic, unanchored mass. When we consider the hidden consequences of a rogue planet intersecting our system, we must discard the Hollywood imagery of a fiery head-on collision. The universe is far too vast, and direct physical impacts between planetary bodies are statistically microscopic. The true terror lies entirely in the silent, invisible transmission of gravitational force. An intruder does not need to physically hit us to erase human history. It only needs to miss us closely enough. Imagine a wandering, frozen super-Earth, a lifeless sphere of ice and iron, 6 times the mass of our planet, drifting in from the interstellar dark. It breaches the Oort Cloud, entirely unseen. It drops through the Kuiper Belt, silently scattering a few dormant comets out of their ancient slumbers. By the time it crosses the orbit of Neptune, it is plunging toward the inner solar system at 80,000 miles per hour, accelerating relentlessly as it falls into the deep gravitational well of the Sun. Because it emits no light and radiates no detectable heat, our optical and infrared sentinels remain entirely blind to its approach. The first warning we would receive would not come from an orbital telescope. It would come from the tides. As the invisible mass crosses the orbit of Jupiter, its immense gravitational field begins to interact with the delicate, interlocking orbital resonances of the inner planets. The unbody problem, the chaotic geometry that Henry Poincare warned us about, violently reasserts itself. The invisible tether connecting the Earth and the Moon would be the first system to feel the strain. The Moon's orbit would begin to warp, its perigee and apogee fluctuating wildly as it is tugged by the approaching phantom. The oceanic tides on Earth, previously locked in a predictable lunar rhythm, would become erratic, towering, and devastating. Coastal cities would be submerged not by melting ice caps, but by the raw physical displacement of the world's oceans pulled by a dark mass in the night sky. But the oceans are merely a fluid skin. The true devastation occurs deep within the planetary crust. The Earth is not a solid sphere. It is a thin, brittle shell of silicate rock floating on a massive, churning mantle of semi-molten magma. As the rogue planet approaches its perihelion, swinging dangerously close to the habitable zone, it exerts a differential gravitational pull across the diameter of the Earth. The physical rock of our planet would begin to flex. If the rogue mass breaches a specific proximity threshold, the mechanics of tidal disruption take over. While it may not cross the absolute boundary of the Roche limit expressed mathematically as $d equals Rm left to frac $, where a planet is physically torn to dust, the tidal forces would still be apocalyptic. The immense frictional heat generated by the forced grinding of our tectonic plates would shatter the crust. The Pacific Ring of Fire would detonate simultaneously. Global supervolcano is dormant for hundreds of thousands of years, would be forcibly ruptured by the shifting mantle. ejecting millions of megatons of ash and sulfur dioxide into the stratosphere, instantly blotting out the sun and plunging the planet into a sudden, artificial winter. And yet, this geological apocalypse is only a symptom of the true catastrophe. The ultimate, terminal consequence of this encounter is the permanent alteration of Earth's orbit. The habitable zone of our solar system, the incredibly narrow band where liquid water can exist on a planetary surface, is mathematically unforgiving. Earth's current orbit has an eccentricity of roughly 0.016. It is nearly perfectly circular. This is the only reason our climate remains stable enough to support complex, multicellular life year after year. When the rogue planet makes its gravitational slingshot around the sun, the strict thermodynamic laws of conservation of energy and angular momentum demand a heavy toll. The intruder will steal kinetic energy from the inner planets to accelerate its escape back into the void. In doing so, it will violently warp Earth's trajectory. Our orbit would be stretched into a severe, plunging ellipse. The psychological horror of this new reality is difficult to fathom. The concept of a year would become a grueling, fatal oscillation between two thermodynamic extremes. As the Earth swings out to its new aphelion, pulled far beyond the orbit of Mars, the planet would freeze. The oceans would ice over. The atmosphere would rapidly thin as gases begin to precipitate out of the freezing air. Human civilization, or whatever microscopic remnants survived the tectonic shattering, would be forced to retreat deep underground, clustering desperately around failing geothermal vents. But then, the unforgiving orbital mechanics would drag the planet back. As Earth accelerates toward its new perihelion, diving dangerously close to the sun, the ice would violently sublimate, the oceans would boil, the atmosphere would become a hyper-pressurized sauna of superheated steam and carbon dioxide. There is no biological adaptation to a climate that violently oscillates between the freezing isolation of deep space and the boiling radiation of a solar furnace. The biosphere would be systematically sterilized. The rogue planet, having executed this elegant mathematical execution, would simply continue its journey, coasting back out into the interstellar medium, disappearing into the dark as silently as it arrived. It would leave behind a deeply scarred, chaotic solar system where the delicate clockwork has been fundamentally and permanently broken. This scenario forces us to look at the night sky not as a protective canopy, but as a vast, fluid ocean where unimaginable masses are in constant, dangerous circulation. The boundary between a living world and a dead, barren rock is separated by nothing more than a few percentage points of orbital eccentricity. We are floating on a cosmic razor's edge, but the hidden consequences of rogue planets extend far beyond the localized, violent threat to human civilization. When we zoom out, leaving the fragile confines of our solar system and looking at the overarching timeline of the cosmos, the existence of these wandering worlds reveals a profound, deeply unsettling truth about the ultimate destiny of all matter. We suffer from a severe temporal bias. We look at the universe in its current, luminous state and assume this is the standard operating procedure. We live in the stelliferous era, the age of burning stars. Galaxies are ablaze with the furious nuclear fusion of hydrogen and helium. It is an era of light, warmth, and complex chemistry. But astrophysics teaches us that the stelliferous era is just a fleeting, microscopic spark in the infinite timeline of the universe. The stars have a finite fuel supply. The thermodynamics of the cosmos are strictly governed by entropy, the relentless, inescapable progression toward total energy equilibrium. Over the next 100 trillion years, star formation will gradually cease. The raw materials, the vast molecular clouds of gas and dust, will be entirely consumed or dispersed. The massive, brilliant blue stars will detonate into supernova, leaving behind silent black holes and rapidly spinning neutron stars. The smaller, cooler red dwarfs will slowly burn through their reserves, eventually fading into dense, ultra-compact white dwarfs, glowing faintly like cooling embers in a dying fire. And then, even those embers will go out. The universe will transition into the degenerate era. The sky will go permanently, irreparably black. There will be no visible light anywhere in the cosmos. The very concept of a solar system will become an ancient, obsolete relic of a brighter past. But the planets will not simply vanish. The mass remains. The trillions of rogue planets currently wandering the void are not just a terrifying anomaly of our present time. They are the vanguard of the future. They are the early adopters of the universe's ultimate state. As the stars die and their immense gravitational holds inevitably weaken, even the planets that survived the chaotic infancy of their systems will eventually be unmoored. Through the slow, agonizing process of gravitational radiation and the occasional close encounter with passing dead stars, the remaining planetary bodies will be gradually stolen from their orbits. Every single planet in the cosmos will eventually become a rogue planet. This is the hidden, terminal consequence of the dark mass. The universe is not a machine designed to harbor life or sustain shining stars. It is an immense, dispersing cloud of freezing, isolated debris. Imagine the cosmos 10 quadrillion years from now, a reality completely devoid of thermodynamic activity. The galaxies have dissolved, their structures torn apart by the relentless expansion of dark energy. All that remains is an infinite, pitch-black void, populated entirely by dead, frozen worlds. Trillions upon trillions of black spheres, drifting alone in absolute silence. They will never see a sunrise. They will never feel the warmth of radiation. They are locked in a state of perpetual, cryogenic isolation, moving blindly through an ocean of nothingness, occasionally passing one another in the dark, separated by millions of light years, entirely unaware of each other's existence. When we look for rogue planets today, we are not just hunting for an immediate, existential threat to our fragile Earth. We are peering through a terrifying window into deep time. We are looking at the final, inescapable architecture of the universe itself. The wandering, starless worlds are not the outcasts of reality. They are the inheritors of it. The darkness is not a temporary absence of light. It is the natural, permanent state of the cosmos. The light we see in the night sky is merely a localized, temporary violation of that dark. A brief, violent chemical reaction that has afforded us the temporary illusion of safety. But the illusion is failing. The sheer, overwhelming mass of the invisible universe is out there, drifting silently, governed by rules that we can barely perceive and absolutely cannot control. As our supercomputers crunch the final variables of the galactic collision rate, looking for a way out of the math, the numbers do not offer a neat resolution. They do not provide a comforting barrier. They only measure the shrinking distance between the light we cling to and the relentless, approaching block 6, When you truly comprehend the scale of the dark mass, the night sky ceases to be a comforting canopy of stars. It becomes a deep, crushing ocean. The brilliant light we see is merely the surface tension. The true volume of reality is the cold, silent void and the wandering leviathans concealed within it. Our entire human history, every war ever fought, every scientific discovery ever made, every monument we have ever built to our own perceived greatness has occurred on a microscopic speck of dust, perfectly balanced on an invisible, highly fragile, gravitational tightrope. We build massive observatories and draft elegant mathematical models to convince ourselves that we understand our local neighborhood. We map the orbits of our 8 planets and treat the solar system like an impenetrable fortress. But it is a fortress with no walls, sitting completely exposed in the path of a relentless, invisible storm. The interstellar medium is not a barrier protecting us from the galaxy. It is the very highway that delivers the galaxy to our doorstep. The rogue planets currently drifting through this medium do not possess malice, they do not harbor intent or targeted destructive purpose. They are driven entirely by the cold, unfeeling equations of momentum, mass, and orbital mechanics. And that is precisely what makes them so fundamentally terrifying. You cannot reason with an equation. You cannot negotiate with a hypermassive sphere of frozen iron and compressed hydrogen moving silently at 2 million miles an hour. It simply exists, and it moves. To look into the dark and realize that hundreds of billions of massive worlds are completely hidden from our eyes is to finally accept our own profound, absolute vulnerability. We are forced to abandon the comforting delusion that we are the focal point of the universe. We are not even a permanent, guaranteed fixture of our own spiral arm. We are a temporary, highly improbable phenomenon, sustained purely by the fleeting, localized warmth of a middle-aged star in a cosmos that is actively marching toward thermodynamic zero. And out there, far beyond the protective magnetic bubble of the heliopause, the true inheritors of the cosmos are already wandering. They are infinitely patient. They have trillions of years to drift, to intersect, and to silently warp the geometry of the space we so desperately rely upon. We are sailing a fragile glass ship through a pitch-black ocean filled with submerged iron monoliths, completely blind to the gravitational currents that guide them. The universe does not owe us stability. It does not owe us a warning. The mathematical probability of a catastrophic intersection is not a distant, abstract theory. It is a silent clock ticking in the dark, measuring down a timeline we simply lack the engineering to see. The next time you step outside on a clear, moonless night, do not just look up at the familiar stars. Do not seek comfort in the distant, ancient light. Look closely at the immense, sprawling black spaces between the constellations. Stare deeply into the absolute, freezing void. Because statistically, thermodynamically, and mathematically, that is where the true weight of our galaxy resides. A silent, frozen procession of exiled worlds moving relentlessly through the deep, unseen, unstoppable, and waiting